so here we go. All right, I changed the title. This is Teaching Old Applications, New Tricks. So I am going to be talking about projecting your globals into tables and classes. So if you're going, I have classes, you don't need to be here. All right? Okay, so my name is Bannon. I work in the support department. I've been at InterSystems for 31 years. See? Yeah, see, I knew you would be, right? Most of these people are too, they just don't know it yet. I work in support, I do SQL performance stuff, I manage the WRC application, so if you guys are logging into the application and filing issues with support and you find that frustrating, that's my fault, and you can talk to me about fixing that. I like to teach people how to do stuff, and lately I've been doing rock climbing and ice climbing with the Boy Scouts, taking up my time, skiing, sailing, woodworking, and walking my dog. Oh, and I'm the guy that owns a chainsaw, and my friend wanted to build a disc golf course, so I'm into disc golf. Okay, so why are we here? What are we doing? So we're going to talk about SQL mapping, and just things I'm going to go over is who should be in this room, who should not be in this room, how I think about global mapping, and what do I mean when I'm saying global mapping. I have a couple of examples that we can walk through. And then the biggest problem that we run into is collation, so I just want to talk a little bit about collation. I love interruptions. I love answering questions. I would love it if I didn't get to go through my presentation because someone had a fabulous question and we use that as an example instead of what I have prepared, because it's more interesting that way and hopefully more helpful for you. So please, if you have any questions, raise your hands and I will try to answer them. All right, so who is this for? This is for anyone that has an application that uses sets and kills instead of using SQL and objects to modify their database. Okay? So if you're directly accessing your globals and you're using sets and kills and you've been going to all these presentations going, wow, look what I could do if only I had a table. Whoa, I could do that if I only, okay. This is for you because this is how you're going to get your data into a table or a class definition. And once you go through this process, you will be able to do all that fabulous. We'll be doing integrated ML. We'll be playing with Python. We'll be doing, I don't know. I don't know any of this stuff because, well, I do old stuff like this. Okay, who this is not for. This is not for someone that has an existing application using classes and objects. This is not something new, secret, super special. No, this is just for old technology for people that haven't gone through the process yet of moving off of direct global access, right? So there's no secret sauce here. We're not doing anything special with this stuff. So if you already have your classes and your tables and stuff, you don't need to be here. Okay. Nobody? Really? Nobody wants to get up? All right, cool. All right, so what do I think about? Well, first of all, when we say mapping it here at InterSystems, it could mean a couple of different things. This is the original, okay? We had it first, right? This is from ISM. This is back in the 90s, before cache existed, before there was global mapping, routine mapping, all that other stuff. This is the original mapping, okay? So I am going to use mapping globals, mapping all over the time. And what I'm talking about is the process, the steps that we need to go through to take a global node and have that appear in a table or a class. So what we do is we define a definition that is a map in the class that describes what the global looks like, so that the class can, so that Dave, right over there, can generate all the code to make it a table. Okay, so I learned from Dan Schussman. Dan Schussman was one of our original sales engineers, 1984 to 2021, hopefully enjoying his retirement. And Dan would always start his mapping classes with mapping is an art form, okay? Especially if you're a new hire and you come in and they're like, we have these things that our data is stored and we heard you can create a table for it, figure it out and do it, right? And you're like, well, what is this data? We don't know. Okay, then it's a real art form, because then you're like, do you think that's a zip code or a social security number? Like, you just have to try and figure it out, right? So there is some creativity. The stuff that I'm going to do today, there's not a lot of creativity in it because it's nice and simple. Some of the globals that people have created over the years, and they're very creative globals. So the art in getting them to fit into a class definition, that can get a little creative. Okay, so When I'm going to map a global, the things that I am looking for, right? 3 basic things that I'm going to need to do. How do I define a row of data? So I need to look at the global, and I need to define what in that global is going to constitute a row, right? So when I'm thinking of a table, right? Tables, rows and columns, right? So I need to come up with what is one row. So what I'm looking for in there is I'm going to look for the columns. So where is that repeating data, right? When does it look the same? And hopefully, you know, in a simple case, one global node is one row in a table, and every global node looks like the other one, and then you only have one table in your global, right? That would be the ideal case, or the easiest one to work with, right? So how many global nodes make it up? How many different tables are within a given global? And then once I do that, then I'm looking at the data. What delimiters are used to separate the data? Is there one? Is there more than one? What are the different fields? Like, how do I want to count the fields? What do I think those fields represent? Is that a $H date, or is that a zip code? I don't know. Well, when you live in New England, it makes it easy because zip codes start with 0, so then you know it's not a times. Right? And then on the subscript side, you know, basically, when I'm thinking about the mapping and I'm thinking about the subscripts, it's how would you traverse this global if you were writing the code yourself, which is basically with $order. So I'm thinking about a $order command. How am I going to get to the first node? A nice simple $order, you start with null and it finds the first value at that subscript level, right? But sometimes maybe the first value that's at that subscript is not part of this table, and you have to start at 100 instead of at null. So how do I get to the first one? From the first one, how do I get to the second one? If there's extra data in that global, it may not be the simple $order. Hopefully it is that simple $order. And then how do I know when I'm at the end, right? Again, $order just returns null. So when we decide we're at the end of our table, we want to return null. Okay. And again, right, questions. You're allowed to ask questions. Yep.
Do you do anything at this point with, like, you know, defining a column or a vector or any kind of consideration like that yet, or is that right?
I've not tried to define a vector index, Dave. You want to do mapping for a vector? We can do a bitmap index. I have examples. We are not going to do a bitmap. I am not planning, I should say, to do a bitmap index today. You can create a bitmap global and map it. So like if you wanted to define a bitmap index and you're using cache SQL storage, that is a possibility.
Well, my question is, if you're going to consider any of those things, would you do it at this point, or would you do it after you get the $order stuff like that, or can you rework it, or what?
Well, I'm not going to worry about an index until I have the master map, until I have the basic global working. So step 1 for me is be able to say select star from table. And then I'm going to worry about the indexing.
Is the scope read only or read write?
Depending on how you write your stuff, so what I'm going to show you today is read write. So when I do this stuff, you'll be able to use inserts, updates, deletes, and object saves. There are some mappings that you can do that get a little more complicated that we're not going to get into, where it then makes the class read only. So it depends on how much art you have to put into your into your mapping as to whether it could be read write or not. Hey, anybody else? I'm sorry?
There will be parameters to make it read only?
There is a parameter, yes. There is a parameter. So you can, if you want your classes to be read only, because you use sets and kills to modify stuff, you don't want someone using a third-party tool. Insert into, yes, you can specify that the table is read only. Yep. All right, so my very simple example is my house global, right? So looking at this global, you know, it looks like we have 3 different types of information up here, right? There's a year at the beginning, there's an address in the middle, and there's a color at the end, okay? There's only 4 nodes in the global up on the screen, and each node follows the same pattern. There's a year, there's an address, and there's a color, right? So I'm looking at that, and I'm going to say that I have one table in my global, and that table has 4 rows in it, okay? Because it all looks the same, it follows the same pattern, and you know, it's very simple. There's not a lot of stuff in here, so I'm going with 4 rows in my one table. The next thing is I'm going to look at the data, and I need to decide how many fields I have in here, right? Well, I'm getting ahead of myself. So here's the first one. I'm going to say one table. And the next one, what's the data look like? So how many columns am I going to have in my table? How many columns do you want in your house table? 3. Okay. Anybody else want something else? 6. 6. 1, 2, 3, 4, 5, 6. Yeah, I'm going with, so it's 3 or 6, right? So do you want what I said, which is year, address, just as an address, and the color, or do you want year, street, city, state, zip, color, right? You know, this is your choice. You have to make this decision, right? I want to demonstrate the fact that 2 different delimiters in one global node is not a problem, and then we can do this. So I'm going to say we have 6, okay? But if I went with my coloring, I don't know if that coloring shows up that well, but there's the 2 different choices that we have on how you want to do that stuff, okay? All right, and then we need to look at the subscripts, right? So what uniquely identifies a row? How do I get from one to the next? And when do I start? Where do I start? When do I stop? And this is super simple, right? So one subscript, each subscript is going to be unique. I start at the beginning, so I don't have to worry about that. Just a simple $order command, incrementing by 1. It's going to find the next one because there's nothing in between. And when I get, if a $order returns null, I'm done. So this is all nice and easy. So this is going to be a very straightforward mapping that we're going to get to do. So does that make sense for everybody? Good. All right, a couple people shaking their heads. So there's the row ID. All right, so now we're going to map it. And of course, we just went over that example, right? So we're all good with that example. So I had to change it for when we're actually going to do the demo, just to add in an additional subscript, right? So now I added some Zillow information about the houses. It's still 4 rows, right? But now 1 row in my table is 2 global nodes, right? So 14 Livoli Road has 4 bedrooms, 3 bathrooms, and whatever the square footage is that's up there, right? So that's still 1 row of information. It's just spread out on 2 different global nodes. So 1 table still. I have a couple extra, 3 more columns now, so I think I'm up to 9. And 4 rows, 1 table. Okay, so I need to define my ID, which is going to be the unique identifier for a row. It's just that integer subscript that we're going to do. So just one property is going to take care of that. And I called that property my ID key, just because. You can call it whatever you want. The name does not matter at all. I call it ID key, or row ID, but you can call it whatever you like. If it has a meaningful thing, give it a meaningful name to you. I need to define an index. I need to define an ID key index. Every class that you have when you're doing SQL storage needs to have a map, needs to have at least one, and it needs to have an ID key index. Okay? So here's my ID key index. It's on the property that I called ID key. And then on the data side, I just listed out, those are all my properties that I have in my class. All right? Does that make sense to everybody? Yeah. That's a keyword, yes. So that's right. If you're using default storage when you create a class definition, we're in control of the storage, we're in control of the global, we're in control of the unique identifier. And we call it internally, we call it ID, right? So if you say select star from table, there's a column called ID that shows up first all the time. When it's listing it out, InterSystems creates that property, and that's the unique identifier. But you don't have to use that as a unique identifier if you don't want to. Even with default storage, you can say, I want to use my social security number as that unique identifier in the subscript. And then you would have a property social security number, and you would define an ID key index on social security number. And then that would be the subscript. So same concept with mapping, and you can do the same thing in default storage if you choose. All right, I have a few disclaimers. Benjamin just walked in just as I get to give Benjamin a hard time about forcing me to put disclaimers in. Oh, I use Studio. You know the adopting curve, right? You know, early adopters, everybody else, I'm like over there somewhere. I will go kicking and screaming with my Studio. So I am using Studio. And I think, am I on the, yep. All right. So we're going to try and map that house global. All right. So I don't know how readable this is for you, but I was trying to get the house global up on the side a little bit so you could see it, so we can try and remember what we're doing when we're playing with Studio over here on the other side. Right? So I'm a terrible typer, so I have the properties all typed in for me already. I defined the index that we needed, right? So the only part that's left here is to create the storage definition and go through the mapping, right? So we have a little wizard thing to create a new storage definition. So I'm going to click on new storage up here. The name doesn't matter, so I always leave it the same. We're doing SQL storage. So I'm clicking on that one, and that's all I have to do in here. So I can click Finish. So that gives me a new storage definition, and it has this SQL storage map. And I need to define at least one map here. Okay, if you have index globals that you want to make use of, we can certainly define index globals in here, and each index global would be its own map. So a class should have more than one, but you need to have at least one. And let me see if I can find the right place to click in this little box to get my wizard to pop up. I should have been clicking while I was talking. All right, so here's my storage wizard. I need to add a map. The default name is map1. I generally leave that alone. What I need, and data, right? Not only do I need to define one map, I need to define that data map. So this is the one that's going to define where all the data exists for the rows in the table. Okay? I'm going to put in my house global name, and then the rest of the stuff we don't need to worry about. These are all for uncommon cases, so we're not going to get into any of those examples today. But if I expand out the map that I created, it has 3 sections. Okay? We're going to deal with the first 2 sections. We're not going to deal with the third section, the row ID section. Dave is very good at his job. He will figure it out for you. Odds are he's going to figure it out, and you're going to make a mistake. So please just leave the row ID section blank. 99% of the time, we figure it out and it works, right? And those couple percent of the times when you actually need to fill something out, you're doing stuff that's way more complicated, and we'll be working with you, and we'll go over that stuff. But just to keep it simple, leave the row ID stuff blank. All right, so I'm going to define these guys. I'm going to try and make that a little bit bigger if I can, so it is easier to see what's going on. So I'm going to add a field. And so now when I'm going to go through these, and I'm going to try and put them in just in the order that they show up in the global. It's going to move them around a little bit as it sorts them the way that it likes to, but just so that I can keep track to make sure that I create an entry here for every field that's in the data of the global. I'm going to walk in order. So the first one is year that I want to create. Right? And it's in the top level node where the row ID is, so the integer 1, right? There are no additional subscripts, so I leave node blank, because node would be if there's an additional node, right? So Zillow, when I get down to that part of the global, will be a node. And my year is in piece 1. And the default delimiter that we use is the up arrow, which is what I use in my data, so that one's all set. Now I'm going to add street. This one is node 2 with the delimiter of the up arrow, so that's right for me, but it's a little more complicated than that because it's also, that's the whole address, and I only want the first part, so I have to put in a comma 1 because I'm doing $2 pieces to get at this one, right? And the other delimiter is a comma, so a comma in quotes, right? So basically, what I just told the code to generate is a nested dollar piece, right? So I'm doing a nested dollar piece where I'm taking the second element using up arrow as the delimiter, and then I'm taking the first element with comma as a delimiter. Yeah? Mm-hmm.
Utilize like ASCII, like ASCII 255,
Yep.
so you just do dollar character 255
No quotes, yeah.
with no quotes.
Yep. Yeah, you can put an expression in there. Yep. All right. City. This time it got it wrong, so I need 2, 2. Got the delimiters right for me. State. 2, 3. Zip code. I should have went with the 3. It would have been faster. Comma 4. And when I make a mistake, somebody please point it out. And then color is node 3 with just 1 delimiter. Okay. And then bedrooms is first. And I need to make this bigger so I can actually have a node. Zillow. 1. Oh, it's a vertical bar. No, because I'm down on this node, right? So I'm on a different node, right? So there's only 1 delimiter on this.
But you're specifying the bedroom.
It's 4, so it's separate.
This is the bedroom here. The first number on the Zillow node is the bedroom, the number of bedrooms in the house. And then 2.5 is the number of bathrooms.
Piece one of the pipe.
Piece 1 of the pipe, right. With Zillow, so I have to add a subscript to where I was, and then it's on the data side, it's piece 1 with the pipe. Yep.
It's hard to see from here. Is that the 2.1 or 2.1? Hope it is.
2 comma in the piece. Yeah, I'm sorry, it's 2 comma. Yep.
I guess I'm thinking about all these extensions, that, theoretically that's only one piece of the primary delimiter, and then there might be additional information.
Yep, right, but I'm mapping what I can see in the global. There might be in other nodes, but right, yes. And so it might not work for all of them, but for the bit of data that I have here, this works. And then area. Okay, so I listed out, oops, I clicked add 1 too many times, so I'm going to get rid of that one, right? So I have all of my properties defined. The only property that I defined in my class definition that I haven't used yet is ID key, because that's a subscript. So I'm going to put that in my subscript section. In my subscript section, I need to define all the properties leading up to and including the elements of the row ID. And right now, that's just 1 number. And what comes after that 1 number sometimes is Zillow, right? Because I have 1 comma Zillow. I don't put Zillow in here in the subscript section. I only define up to my row ID, which is just that first subscript. So I'm only defining 1 subscript here, and it's going to be my simple integer ID. If there was a constant as the first subscript and my unique identifier was the second subscript, I would have to define 2 subscripts in here. Okay? So it's everything up to the last part of your unique identifier. And then anything that comes after the last part of your unique identifier is going to be a node in the data section. Okay? So I'm going to add subscript 1, and the expression is ID key. So this ID key here, you'll notice, if you can tell, it's probably really hard to tell on the screen, it's in curly braces. Okay? Because as it says at this column heading, this is an expression. Okay, this is an object script expression. You can type in any object script expression you want in here, And when you're referring to a property or a field, you put it in curly braces, right? So we need to be able to tell the difference. Is this a object script variable, or are you referring to a field in the table, a property in the class? And the way that you tell us that this is a property in the class is by putting it in those curly braces. Okay? This is a nice simple example, so my expression is just the value of the property. So curly brace ID key. Okay? So I've defined my data section and I've defined my subscript section. So that should be all I have to do, because I'm going to leave my row ID section blank because I don't need to do that part. So if I click OK, so that was all using the wizard, right? And it's not required that you use the wizard. You can do this if you're a good typer and you remember all the syntax. You can type this all out on your own, right? So here at the bottom of the class definition is our storage definition, and we have all of our data. Right? So here's the area property. It has a delimiter of a vertical bar. It has an additional node as Zillow, and it's the third piece. Right? So everything that I typed in the wizard is displayed right here, and we do the same thing for every single property. And if I scroll down to the bottom, it's going to have my global, up arrow house. It's going to have my subscripts. I only have one subscript. Subscript number 1 is my ID key, and here's my ID key expression, and the map type is data. Okay? So if you're a good typer and you want to do this, you can certainly work here. When I'm working on a more complicated class, I always use the wizard to put all of this stuff in, but if I actually have to write code, because it's not a simple dollar order, for example, I have to write code to get from one node to the next and loop over these things, I would much rather write the code here than in the wizard, because the wizard windows are really little. All right, so I'm going to compile and see if this actually works. All right, well, it compiled. That's a good sign. So now if we go over to the system management portal, we're in the SQL section. I'm going to try and grab this guy and run a query. And there you go. Oh, make that bigger. Plus. All right, so we just were able to take a global, albeit a very small, simple one, define a map in a class definition that describes the location of all of our data in that global, compile the class, and run a query. Okay, so I now have SQL and objects, right? Because I mean, if you have a table, you have a class definition too. So I now have the ability to look at this data, and in this case, modify this data using objects in SQL. All right, so now I can use integrated ML to figure out information about where I lived, or not. I mean, I can, but yeah, whatever. All right, cool. Any questions on that? Nope. All right. Go back here. Is this going to work? Yeah. All right. All right. So the next thing we're going to do is we're going to talk about a parent-child relationship. Benjamin's still here. So again, legal disclaimer. Parent-child relationships are frowned upon at InterSystems. If you are designing something new, please use foreign keys. Foreign keys give you the same functionality, but they don't have limitations of the relationships. So, bitmaps, columnar, and that good stuff. So, we do not recommend that you use relationships. Unfortunately, or fortunately, you already have a global. So it's not really your choice whether you're going to use, if you're going to do it or not, because, well, my global already looks like this, and I'm not changing my global. That's why I'm here. If I was willing to change my global, I wouldn't have to sit through Brendan's presentation. I would just create a new class. Thank you very much. But, all right, so here's my global. This is my family. I only included my in-laws because my wife is one of 7, and then the global would be really small, and you wouldn't be able to see anything, because that side of the family is just way too big. So Same thing that we got to go through again with this process. All right, so now we're looking at a global. It's a little more complicated. There's a bunch of different subscripts in it, and there's a bunch of data. This data doesn't all look the same. All right, so I don't think this is one table. Okay, I'm going to say that it's 3 tables. Okay, so I'm going to go with my parents. Right, so Tom and Bridie up there at the top, those are my parents. Paul and Agnes down the bottom, those are my in-laws. Okay, and then there's the children, me and my siblings in salmon color there, Peter, Sheila, Brian, and Brendan. And then our kids, the grandchildren, in the teal color. Okay, so I'm going to say we have 3 classes: the grandparents, the parents, and the children. I'm not sure that's what I called them. I can never remember what I called them, but anyway, right? Those 3 different classes. Okay, so for these 3 different classes, we need to define the ID. Okay, if we look at the grandparents, or all right, I call it parents, global summer parents, it's nice and simple. It's just like the house example, right? There's just a simple integer, 1 subscript, nothing to do there, right? So that's easy. The ID key for the parents is just an integer. We only have 2 rows in that table. Okay. The child class has 3 subscripts. Okay. 2 of them are integers, 1 of them's a constant. Okay. The first one looks the same as the parent one, right? So this, the 1, if there's a 1 here, right? So if I had the data, you could show it. Because there's a 1 here, that means it's me or my siblings, because that goes with the parent up above, right? So if I go back and look at the global, right? Anyone that's related to Tom and Bridie has a subscript of 1. The first subscript's going to be a 1, because they're related to Tom and Bridie. If I had a little bit of my in-law side of the family, you would see then there's subscript, other nodes with subscript 2, and those are all my in-laws. So to define the ID of the child table, I need to use 2 values. I can't use just the first subscript because, well, then I would be my parent and that would get really confusing and I don't want to be my parent. So I need a second subscript to tell the difference between my parent and me and my siblings. So 1, 1 is my oldest brother, Peter. 1, 2 is my sister, Sheila. Right? I need to use both of those values to uniquely identify a child in this one, okay? And then in the grandchildren, I have 5 subscripts, and I need to use 3 integers to uniquely identify a grandchild. I need to know who the grandparent is, or who the parent is. I need to know the child, and then the grandchild. Right? So 1, 1 is Peter's oldest child, Annie. 1, 4, 3 is my daughter, Robin, right? Because I'm the 4th child of my parents, right? So I need to identify the ID 3 different subscripts, okay? That makes sense? All right? And then the last little bit down at the bottom, when I'm defining the ID, I need, I'm only using the integers. I'm not using the constants. When I do the mapping, I need to remember to include the constants because I need to, I don't want a dollar order on subscript 2. I just want to stick that constant in there. I want a dollar order on subscript 1, 3, and 5. 2 and 4 are constants. I don't want a dollar order on those, but I have to make sure I keep those placeholders when I'm doing the mapping. Okay, all right. So for the parent, I have 2 simple properties, right? I have partner 1, partner 2 from mom and dad. I have the ID key, which is just 1 property, subscript 1. Right? And that's going to uniquely identify that 1 property. And then I have a relationship property, just like with default storage. I define a relationship property the exact same way. So I'm in the parent, and the cardinality is the value, what I'm pointing to. I'm pointing to a child table. And I'm going to have a property down there called parent ref. Excuse me. Sorry about that. Does this make sense? Okay. So this is what it's going to look like right? When I showed you the bottom, what the storage definition looks like and the class definition, right? So this is what the subscript is going to look like for the parent. It looks exactly like the subscript that we defined for my house class. Nice and easy. Okay? For the child, right? I have a child and a spouse. I have property subscript 3, which is the integer, which is part of the ID. So this is where it gets confusing, and this is why we're doing a parent-child relationship example in the class, because this is a little weird. I need to define the properties that are in this class. And the properties that are in this class are not the properties that are in the parent. Subscript 1 is the ID of the parent. It's not in this one, okay? It's part of the ID of this one, but it's not a property in this one. So it's a little weird. So I only just define subscript 3. Okay? You need to remember about subscript 1, and we're going to come back to that in the mapping section, but I don't define subscript 1 as a property. Right? So I have the 2 regular properties. I have my subscript, which I'm using as the ID key, and then this is the middle class, so I have 2 relationships, one pointing back to my parent, one pointing down to its children. Okay? And now in the storage definition, we need to tell the storage definition about all the subscript levels, which means I need to deal with that subscript 1. I didn't define a property for it, so I can't just say subscript 1 because there is no property called subscript 1. So I have to use the full reference to where subscript 1 really lives. So it's schema.table.property. So gs23.parent.sub1. Okay? Constant is subscript 2, and then sub 3 is subscript 3. All right? So this is the trickiest part. This is the part that I always get wrong the first time I do a parent-child after a few years, and this is the most popular question that I get when people are trying to do mapping, is they're trying to figure out how to do the parent-child relationship. It's remembering that you have to do this weird full reference to the parent. Okay? Does that make sense? Well, Chip, yeah, you're nodding, at least one. Or you're just chewing. Grandchildren, right? Same thing with the grandchildren. I'm only describing subscript 5. I'm going to need those other 2. I need subscript 1 and subscript 3 again, but I don't define them here. So it's just subscript 5. I define my ID key on subscript 5, and I have a relationship pointing back to my parent. And then defining my child, full row reference for the first 2 values, right? Schema.table.property from the grandparent, schema.table.property from the parent, and then subscript 5. Okay? All right. So Benjamin's going to get mad at me because I have 5 minutes left, so I'm skipping my demo. So I can do objects now. So how many people have worked with parent-child relationships and used an object with the parent-child relationship? You can now do all that with these 3 classes. Honest, you can. You can. So I can run a query against these things. I can do joins between these tables. I can instantiate the objects. And again, this was nice, simple mapping in here. So I can do %save, right? I could now type in the 13 grandchildren, 7 children and 13 grandchildren, and 7 spouses on my other family side using objects. But I'm not going to. I'm sorry? Yeah. Yeah. Yeah, right? So it would just be, the relationship property kind of is, right? The reference back to the parent. Yeah, so if you had, you would define it the exact same way. It's like, I have this 27 in here. What is that? Well, that's pointing to the state table. So you would define your property of my type state and map it to that location where that 27 is in the global, and there you go. You have extended syntax and dot syntax in objects. Yep. Okay. So the second most popular problem that I have with customers when they're using SQL storage is they set up their SQL storage and everything's working and they define their indices and it's still slow. Why is it slow? Why aren't you using my index? Well, we're not using your index most likely because you set the collation up wrong. Okay? You need to match the collation of your data with the definition that you have in your class. Okay? So here's my example. My kids get to be in here twice. My pets get in here as well. So in my pets global, up here, right, I have their name and the type of dog that they are. And then down at the bottom, I have an index on name. Right? The first subscript is just a constant name. The second subscript is the name of my dogs. And notice that the way that the name of my dogs appear in the index looks exactly the same, exact, that's the important word, as it does in the data. Okay? But on my kids' side, the name of my kids are up in the data up there, but when they're in the subscript down in my index, in my name index for my kids, they're all in uppercase. Okay? The collation of my data for my kids' names in the index does not match the collation of the name in the D global. Right? So I need to tell my class definition that when you're going from my index to the data, or from my data to the index, that you need to perform a transformation to change the data so that it matches. When I use a where clause in my query, I need to make sure that I'm using the right format. Right? So I need to change whatever you give me, I have to convert it to alpha up and do a comparison, because that's the function. That's an old FDBMS collation, right? So I need to, in my mapping definition, I need to make sure that my class definition properly describes these two different cases, right? So I have exact collation for my pets, and I have alpha up or SQL upper or whatever collation you want, just a collation on the other side. Okay? So I need to tell the system. So I need to tell the property up at the top. My property, my pet name has exact collation, and then when I define the subscripts of my index, all I have to do is say curly brace name, because it's exactly the same. I don't need to do anything, right? So you just have the property definition, say exact collation, and you leave the index alone. 99% of the time for customers using Cache SQL storage, this is what you do, because your index is going to have exact collation. I almost never see indexes with collation. All right? And then for my kids, the collation didn't match in the global, so I need to deal with that. So I have the collation as alpha up for the property, and then I need to have an expression down the bottom, $$ alpha up. This is a function that we provide for you. You don't need to write that function. Dave will co-generate it whenever you reference it. So you just say $$ alpha up, open paren, curly brace name, close, close. Okay? And this will tell the system, whenever I deal with these properties, if I see a where clause, I want to do a case-insensitive search.
Can you explain why you wouldn't do that? You said just leave it alone, don't do it.
So when you look, wrong way. When you look at the data, if the data is the same in your global, right? So this is the global that I do my mapping on, right? This is my data global, my D global, and then this is my index. The data here looks exactly the same, right? So I don't need to do any transformation, right? So this would be called exact collation, no collation, which means when you define the property, you have to say property collation equals exact. And the reason why you have to say collation equals exact is because Cache objects has a default collation of SQL upper. We assume you always want a collation, so you have to, when you want to use exact, you have to tell us.
I think what's missing is when would they be different? I mean, isn't there supposed to be a procedure to keep your indexes even in the old way? So you do the data. Why would one be alphanumeric? Sorry, why would one be uppercase and the other one mixed case? Like, it doesn't make sense.
Because that's, I mean, the index needs to have a one-to-one correspondence with the data map. Because this allows me to have a case-insensitive search. I can say where name equals, and I can type Caitlin all in uppercases, all lowercase, all mixed case. It doesn't matter what case I type it in. When we do the comparison, we're going to make both things all uppercase, and then I'll get a match. Over here, if I want to find a match of Griffey, I need to type it in exactly right. I need to type it in with an uppercase G, everything else lowercase, or I won't get a match.
Is that what you do when you just create a class native with a data name?
Yes.
That way you store the indexes and for that in uppercase?
Yes. So the difference, if we were using default storage, the real difference would be there'd be a space right here. And then it would be collation. Yeah, so you can look, right? You know, the top global is your D global. If you're looking at default storage, the bottom global is your I global. You can look at the I global, and you'll see if you just define a property and you just say property name, index on name, populate 10 rows, the names are all going to be in uppercase in the index, because we assume that you're going to want a case-insensitive search. Okay? Any other questions? All right. I just ran out of time, so I'm just going to say this is just the very simplest, smallest thing, right? I only showed you how to do 2 mappings. That's enough to probably get you through 80% of all the mapping you need to do. If you can do a parent-child relation, if you can do a simple mapping, and then you can do a parent-child relationship, that's like 80% of the work. Okay? But there is so much more that we can map. You can come up with the craziest global structures, and a lot of people have, and we can map it. All right? So I skipped over a lot of different things. There's a lot of different types. So let's see, on your left-hand side, those are all different features that are part of our mapping storage that I did not talk about at all. And then on the right-hand side, a bunch of different names of classes that I did for examples of mapping. So customers call up and they say, I have a global that looks like this, and I'll create a little global and I'll do a little mapping for them and I'll save it. I have 75 different examples that I give out to you. I also have a 5-part trilogy on what? The art of global mapping on developer community. Thank you, Benjamin. So this will walk through a simple example, a parent-child relationship, and then some more complicated examples. If you can hang through all the way to the 5th one, finally at the 5th one, the answer is 42, and there's the zip file with all the examples in it. Okay? If you don't want to sit through all the examples, you can send me an email, and I'll just send you all of the examples. You can also ask me a question, and I might answer it too. Okay? Yes?
When I was learning this stuff, and I saw your article, it was great. It was impossible to find the actual reference.
The reference.
The reference to all this stuff, like what is, we use this thing called invalid condition.
Okay.
I don't know why it's there. Like we use it.
Uh-huh.
It's got this special expression and stuff. It would be nice to know the entire reference of all of that and know that I can find.
Okay. There's a really good book from 1997, Open MSQL Data Dictionary Guide, that describes every single part much better than my document. I'm sorry?
Is the book authored by InterSystems?
Yes, it's the InterSystems documentation from 1990 something.
And it's not online?
It's in a PDF format somewhere. In documentation, yeah. And again, if you send me an email, I can certainly, I'll find it and get it to you. And if you have specific questions, like if you want to know what invalid conditions are and when you need to use them, I'm more than happy to answer that question, right? So if you guys are doing any of this stuff, please shoot me an email. I like answering these questions. Send me your hideous global. I'll try and figure out how to map it for you. I like doing this stuff. Yes?
In the app, I was looking for the attachment, it was pointing to a different PDF.
Uh-oh. All right, I will talk to the powers that be. That is way beyond me. That's a modern application. I deal with 1997 applications. Anybody else? Well, all right, thank you very much.